So we have 4.857 as our chi-squared test statistic. So now we can go to our chart for the chi-squared test statistic and look up what the p-value is. The p-values or the tail probabilities will be up here, degrees of freedom here. Now we have 7 days of the week, and as I said before, the degrees of freedom are the number of categories minus 1. So each day is a category. So we have 7 categories, minus 1 is 6. So we have 6 degrees of freedom. So we're going to go down this column and look for the number 6. Right there. We read across this column and try to find the test statistic we are looking for. In this case, we're looking for 4.857. Well, notice that the chi-squareds get bigger over on this side, so they must be smaller on this side. Well, the probabilities get smaller on this side and bigger on that side. So that tells us that our p-value must be greater than 0.25. Okay, so this value is 0.25. We know we're to the left of this because 4.857 is less than 7.3, so this has got to be over here. That tells us our p-value is greater than 0.25. This is a very large p-value. So this is highly probable that it could happen by chance. This sample could have very easily happened by chance. More than a quarter of the time it will. So, just like we did before, since it is so probable, we fail to reject the null hypothesis. Since we fail to reject the null hypothesis, there is not enough evidence to say that the proportions of births are not the same for all days of the week. This is not saying that they're all the same. This is just saying that we don't have enough evidence to say they're not the same. We can now look at the spreadsheet that I created for you. This is a spreadsheet that calculates everything for you. All I had to do is enter these 2 rows, and everything else is calculated for you. Notice again, it says the same test statistic that I got above. The spreadsheet did that for us.